Do you want to know what is semi-supervised learning? Then this video is for you. In this video, we will discuss about what is semi-supervised learning. Next, why is semi-supervised learning important? Next, we will discuss about semi-supervised learning algorithm, SGAN. And then, what are the practical applications of semi-supervised learning? Before going to these topics, if you are new here, this channel basically explains the concepts of AI, ML, DL, DS and motivates you to these fields. If you are interested, consider subscribing my channel. And if you don't know what is supervised and unsupervised learning, feel free to watch this video. Link is in the description. Now let's dive right into the topic. Semi-supervised learning. Semi-supervised learning algorithms represent a middle ground between supervised and unsupervised algorithms. Although not formally defined as a fourth element of machine learning, it combines aspects of the former two into a method of its own. These algorithms operate on data that has a few labels but is mostly unlabeled. Semi-supervised learning uses the classification process to identify data assets and clustering process to group it into distinct parts. Since labels are expensive, especially at the magnitude most datasets exist at, large datasets may only have a few labels. For instance, consider determining if user activity is fraudulent or not. Out of 1 million users, the company knows this for 10,000 users, but the other 90,000 users could either be malicious or benign. In general, semi-supervised learning algorithms operate on this framework. A semi-supervised machine learning algorithm uses a limited set of labeled sample data to train itself, resulting in a partially trained model. This partially trained model labels the unlabeled data. Because the sample labeled dataset has many severe limitations, the result of labeling are considered to be pseudo-labeled data. Labeled and pseudo-labeled datasets are combined, creating a unique algorithm that combines both the descriptive and predictive aspects of supervised and unsupervised learning. A semi-supervised algorithm assumes the following about the data. Continuity assumption. The algorithm assumes that the points which are closer to each other are more likely to have the same output label. Cluster assumption. The data can be divided into discrete clusters and the points in the same cluster are more likely to share an output label. Manifold assumption. The data lie approximately on a manifold of much lower dimension than the input space. This assumption allows the use of distances and densities which are defined on a manifold. Why is semi-supervised machine learning important? When you don't have enough labeled data to produce an accurate model and you don't have the ability or resources to get more data, you can use semi-supervised techniques to increase the size of your training data. For example, imagine you are developing a model intended to detect fraud for a large bank. Some fraud you know about, but other instances of fraud are slipping by without your knowledge. You can label the dataset with the fraud instances you are aware of, but the rest of your data will remain unlabeled. You can use a semi-supervised learning algorithm to label the data and retrain the model with the newly labeled dataset. Then you apply the retrained model to new data more accurately, identifying fraud using supervised machine learning techniques. However, there is no way to verify that the algorithm has produced labels that are 100% accurate, resulting in less trustworthy outcomes than traditional supervised techniques. Algorithm. Semi-supervised GAN. The semi-supervised GAN, abbreviated as SGAN for short, is a variation of the generative adversarial network architecture to address semi-supervised learning problems. In a traditional GAN, a discriminator is trained to predict whether an image is real or fake, allowing it to learn discriminating features from images even without labels. Although most people usually use the generator in GANs, which has been trained to produce images that resemble those in the dataset, to produce realistically generated images. The discriminator can also be used to transfer learning as a beginning point to develop a classifier on the same dataset, allowing the supervised task to benefit from the unsupervised training. Since most of the image features have already been learned, the training time and the accuracy to perform classification will be much better. In SGAN, however, the discriminator is trained simultaneously in two modes, unsupervised and supervised. Semi-supervised GAN involves directly training the discriminator model for the both unsupervised GAN task and the supervised classification task simultaneously. The entire dataset can be passed to the SGAN. In order to train these two modes simultaneously, the discriminator must output values for 1 plus n nodes, in which 1 represents the real or fake node and n is number of classes in the prediction task. While allowing the SGAN to train unsupervised allows the model to learn very useful future extractions from a very large unlabeled dataset, supervised learning allows the model to utilize the extracted features and use it on a classification task. The result is a classifier that can achieve incredible results on standard problems like NIST, even when trained on a very few labeled examples. The SGAN cleverly combines aspects of unsupervised and supervised learning to strengthen each other, allowing for the best of both worlds to work together to produce incredible results with minimal labels. Practical applications of semi-supervised learning. Speech analysis. Since labeling of audio files is a very intensive task, semi-supervised learning is a very natural approach to solve this problem. Internet content classification. Labeling each web page is an impractical and unfeasible process and thus uses semi-supervised learning algorithms. Even the Google search algorithm uses a variant of semi-supervised learning to rank the relevance of a web page for a given query. Protein sequence classification. Since DNA strands are very typically large in size, the rise of semi-supervised learning has been imminent in this field. That's it. If you like this video, leave us a big thumbs up and subscribe to our channel for more updates like this.